right, so today 7.1b, we already know law of signs. We are today looking at the ambiguous case is what it's called. Is that how you spell ambiguous?
That's how I spelled it, but I could be wrong.
Ambiguous. Yes. So we're looking at the ambiguous case, which is what happens. So normal law of signs that we did on Friday, what did we do? We did angle, angle, side, and angle, side, angle. Is that what we did? Okay. Today's our side, side, angle triangles. And the temptation to write this as the ambiguous case is like really high, but I'm not going to. Okay, so but that's how you can remember it. So this is what we do with a side-side angle triangle. So the first thing that I want to do is I want to rewrite law of signs for us so we have it here nice and fresh. So our law of signs is sine of, which one's capital? Yes, sine of A over little a equals sine of big B over little b equals sine of big C over little c. Also, we can use the inverse of that. We can do A over sine of big A equals little b over sine of big B equals little c over sine of big C. So that's what I showed you guys that proof of last week. I just want to show you guys that we can flip them all if we want to. Okay. Whoever explains something out loud, go ahead and turn it off for me, please. All right, so here is the ambiguous case of a angle side side or a side side angle triangle. So basically, what we know is we know this angle. Hey, can you guys stop talking over me, please? We know this angle of the triangle. So we're going to label this angle A down here. And we know this side length B. Then the mystery and what makes this ambiguous is what this side length A is here. So I'm going to draw in 3 different colors what can happen. So, yes. Oh, the pink, yeah. I will put it away. Yes, what's your question?
What does ambiguous mean?
Ambiguous means like we're not sure what it's going to be.
Why is that B a little B, not a big B?
This one right here?
The one in the
this one right here?
No,
this one right here, because it's a side. Sides are little letters, angles are big letters. Okay, so we know angle A, we know side B. Then we know the length of the side across from angle A. So one of 3 things is going to happen. The first thing that can happen is that we can have one triangle be created. So if this is A, that's going to lead to one triangle. And everything works out just peachy keen. And I will tell you when that happens in a moment. The next thing that can happen, I'm going to do this one in blue, is we could have my angle A could be a length where it could make 2 different possible triangles. So my angle A, or my side A, could make 2 different triangles. The third thing that could happen, and I'm going to do this one in green, is that my side A isn't even long enough to reach, and I am not able to make any triangles out of that. So you are going to end up with 1 triangle, 2 triangles, or no triangles today. For each problem, we're going to do 1 example of each, and then there's 2 of each on your assignment. For each problem, it's going to give you the option, and it's going to say on Math Excel, it's going to say 1 triangle is created, and then it'll have you fill them in, or 2 triangles are created, it'll have you fill in and solve both triangles, or no triangles are created, and then you'll just say no triangles are created. Okay. For these triangles to work, here is when each of these things is going to happen. You are going to have one triangle if A is greater than H. I'll show you what H is in a second. And A is greater than B. So H would be this, the height of the triangle. So if A is greater than H and A is greater than B, you're going to have one triangle. You will have no triangle if A is less than H, because if that side length is shorter than the height of the triangle, it cannot reach the bottom of the triangle here. Okay, and then the last one, you'll have 2 triangles if A is greater than H, because A has to be greater than H to create any triangle, because you have to be able to reach the bottom here. But then if A is less than B, it means we can make this fun little weird obtuse triangle here and this acute triangle here. So you don't really need to stress out about this, because you will see as you do law of sines which one it's going to end up being. And you will see the mathematical impossibilities that created that make it so it's one triangle, or make it so that's no triangle, or make it so that's 2 triangles. Impossibilities only actually make it so it's one or none. All right. Any questions right now? I don't expect for any of this to make sense yet, but does anyone have any questions right now? All right. Let's see one of each of these in action. So the first one that we are going to do, we are going to solve triangle ABC if A equals 43 degrees, so angle A is 43 degrees, sorry. Side A is 81.
Didn't you say we'll always have like 3 pieces of
Mm-hmm.
information?
And side B is 62.
I remember doing this in algebra 1, and they were saying like, if there's not enough information, we can just check no, not enough.
Okay, there will be enough information on all of your problems today. All right, so let's go ahead and draw this triangle. Here's what I know. I know that this is 43 degrees. I know that side A across from 43, I should label that, sorry. Side A has a length of 62. And then this is going to be side B, has a length of 60. Just kidding. Side A is 81. I'm sorry, guys. B is 62. Okay. And then we do not yet know angle B, angle C, or side C. Okay, so this triangle, I went ahead and drew this triangle because I know that A is greater than B. And so that means I'm going to have one triangle. Because A is greater than B, I have one triangle. So I know right away this is going to yield me one triangle because A is greater than B. So 81 is greater than 62. Okay, So then from here, this is a normal law of sines problem. Now that I've determined that I'm going to have one triangle, this is a normal law of sines problem. So if you were doing your 7.1a assignment and didn't know how to get problems started, here's how you get a normal law of sines problem started. We can use either this version or this version. I'm going to choose to use this version. Am I? No, I'm going to choose to use this version because I know more sides. I was like, do I know more sides or angles? I know more sides than angles, so I'm going to choose to use this version. So I'm going to do a over sine of a. So that is going to be 81 over sine of 43. Okay, what's up?
Where did you get the one triangle?
Oh, just because a is greater than b. If a is greater than b, you will always have one triangle. That is just a rule. So in this example, you will only get one triangle. Okay, so 81 over sine of 43 is going to be equal to, let's go ahead and solve for b first. So it's going to be 62 over sine of big B. I should have used the other one. I'm a silly goose. Oh well. Too late. Okay. I can then cross multiply this. I'll have 81 sine of B equals 62 sine of 43 degrees.
Okay.
And then we can divide both sides by 81. And then sine of B will equal this. Okay.
I'm confused.
What are you? Where did I lose you?
Why are there so many 81s?
There's only, oh, right here. So this, okay, this was 2 steps. Okay, so are you good with what I wrote in blue?
Yeah,
All right, then I cross multiplied and got this.
kind of. Why did you pick those numbers?
Because that's A over sine of A and B over sine of B.
And those are the sides we have?
81 and 62 are the sides we have. Then I cross multiplied and got what I'm not covering up right now.
Uncover.
Okay, 81 sine of B equals 62 sine of 43. I'm trying to answer Mason's question. Are you good until there?
Yeah.
Then, to get sine of B by itself, I divided both sides by 81, and those just canceled, and then there's the 81s over here now.
Affirmative.
All right, so then, if we know what sine is equal to, we are now going to use sine inverse. So we are going to do sine inverse of all of this to find what B equals. So B equals sine inverse of all of this. And I'm not even going to rewrite it because I'm lazy. Okay, I'm going to go ahead and plug that into my calculator. Sine inverse of 62 sine of 43 divided by 81, close parentheses. Make sure your calculator's in degrees. I'm going to get 31.5.
And we could just put all of that in the calculator. The sine would be like 62 sine. Put all that in the calculator.
Yeah, that's what I just did. Okay, so that means my angle B is going to be 31 degrees. They want me to round it to the nearest degree. Okay, put that to the side, wait until we're done with notes. Okay, so B is 31 degrees. At this point, it's also important to point out that if B is 31 degrees, and I actually should have had you guys do this first. So 62 sine of 43 divided by 81. We knew this was going to be one triangle, but this right here, so sine inverse is 0.5220. I would need to note the fact that if this is going to be one of my angle options, I could also have another angle between 0 and 180 degrees that has a sine equal to 0.522, but that angle is going to be, I just messed that up, 180 minus 31 degrees. That angle is going to be 149 degrees, and we cannot have a triangle that has an 149 degree angle and a 43 degree angle, because that puts us over 180, which is mathematically impossible. So since at the beginning I said that we were only going to have one triangle, we only need this to be one triangle. So my B here equals 31 degrees, and I can go ahead and label that here. Then I can go ahead and solve for my third angle. So that'll be 180 minus 43 minus 31. And I'll get that my third angle, angle C, is 106 degrees.
Oh.
43 plus 31.
Okay. And then once I've done that, I can now use that 106 degrees, and I can use my original ratio to solve for C. What's up?
I have a question.
Yes.
Since B was equal to like 31.5,
Mhm.
why not just round up to 32?
Was it equal to 31.5?
Yes.
Did I
Well,
make that
rounded
up?
up.
No.
That would be rounded up twice then.
I'm gonna be honest, I could be wrong. I've been hallucinating a lot of things.
That would round it up twice. That was like
Yeah. So 31.4. It wants it to the nearest degree.
Oh.
Yeah. If it wanted it to, we wouldn't round it to 31.5 and then round that up to 32. He's wrong.
Okay.
So since it wanted it to the nearest degree, you like threw me off there for a second. I was like, wait, what?
Well,
Right,
you
yeah.
said 31.5. You didn't say.
I said 31.5, and then I looked back down and saw that it wanted to be rounded to the nearest degree. That's what happened.
Yeah, but you didn't communicate.
I did not communicate that. You are accurate. Communication is hard. Okay, so any questions about finding angle B, finding my third angle? Okay, so stop talking over me, please. I don't care if you're paying attention, but I do care that you're not interrupting me.
Stop making it seem like you don't know nothing in your class. We're literally paying attention.
Okay, so I now know my other ratio. So I'm going to do 81 over sine of 43 again. But this time I'm going to set it equal to C over sine of 106. Little c over sine of 106. Okay, I can go ahead and cross multiply that. I'll have 81 sine of 106 equals C sine of 43. And then I can divide both sides by sine of 43. These guys will cancel, and I'll have C equals this whole thing. No, because it's not a right triangle.
Oh.
So we have now moved on, and we are learning law of sines to be able to solve oblique triangles that are not right triangles. So then I've got 81 sine of 106. Make sure you close those parentheses after the 106, because otherwise the sine will go inside the sine, and then divide by sine of 43.
Why do we have to write the whole extra step of equals C sine of 43 over sine of 43? Because that's just cancels out with itself. So you just put equals C if we're trying to get C by itself.
If you would like to show your work in a different way, you may.
Oh, I didn't know if that was like Mando.
No. So if you would like to just multiply both sides by sine of 106 in this one, you can. I just always cross multiply and solve for what I'm looking for. All right, and I get 114.2. They want us to round it to the nearest tenth on this one. So 114.2 is side length C. Little c is 114.2. So, recap. If at the beginning of your problem, A is greater than B, you can just normal law of sines the entire way through. Any questions right now before we move on to the ones where we have to determine whether there are no solutions or one solution? Are you here for food? Yes. Why did I flip what? Like, why did I do this instead of this? Because I thought, and this instead of this? Because I thought it was going to save me time, and it ended up being about the same amount of time. It doesn't matter which one you use. Because since they're ratios, as long as you flip all of them or flip none of them, it works. Okay, any other questions? No. All right, let's go ahead and talk about our next example now. So the next example I have for you, A equals 75 degrees. Big A, sorry, yes. It's an angle. Big A equals 75 degrees. Little a equals 51.
Is this the last example we're doing?
Nope, this is the second to last. We're going to do all three different possible things. So having one triangle we already did, we're going to do an example where we have no triangles, an example where we have two triangles. Because of all the things that you need to know how to do. And then little b is 71. Okay. So, we can go ahead and draw this triangle. I know this is going to be side or angle A, and this is going to be side length B. And then my angle or my side A across from here, I don't know where it's going to go to exactly yet. But I'm going to go ahead and label that.
What happened? Why does it look like that?
Because I don't know if I have a triangle yet. Because A is not greater than B. So since A is not greater than B, I don't know yet if I'm going to have one triangle, or actually, I know I'm not going to have one triangle.
Where do we see that visually, though?
Okay, since A is not greater than B, I don't know yet if I'm going to have no triangles or two triangles. So I can it's either going to connect in two different places.
I see how it connects in two different places.
Mm-hmm. So it's either going to connect, so either this is going to happen, where it's going to be long enough to connect in two places, or it's not long enough at all, and it's not going to connect in any places, which is what I drew.
How would it connect in two places?
What's up?
How do we find H? Is that what we're doing?
So we do not need H. What we're going to do, hold on just a sec. You'll see how it doesn't work in a second, okay? It doesn't work. Yeah. Okay, so our known ratio is A over sine of A or sine of A over A. It doesn't matter which one we use. I'm going to do A over sine of A. So yes.
How would there be two sides, though?
How would there be two triangles?
Yeah.
It's two different triangles. It's not that it's a triangle with two sides. Or draw triangles with two sides.
How do we get two different triangles? Yeah.
So this example is the no triangle example. Let me finish this one and then you'll see on the next one, okay? All right, so our known ratio is A over sine of A. So we've got 51 over sine of 51. You have no room to be talking. Equals 71 over sine of 71. I do. Happens when I get interrupted like 16 times. Okay, 51 over sine of 75 is 71 over sine of B. All right.
That's sine 25.
75. So A over sine of A equals B over sine of B. That's what I've set up so far. All right, I can go ahead and cross multiply this, which is going to give me 71 sine of 75 degrees equals 51 sine of B. I'm going to divide both sides by 51. I now have that sine of B equals 71 sine of 75 degrees over 51. Okay. Instead of doing sine inverse right away, I want to show you why what's going to happen is going to happen. Okay. I'm going to go put 71 sine of 75 divided by 51 on my calculator, and I'm going to get that sine of B equals, let's leave that with 4 decimals, 1.3447. What is the output? What is the range of sine? -1 to 1. Yeah. So sine can only be as low as -1 and high as +1. So if I go to do sine inverse of this, sine inverse of my answer, it's going to give me an error because that just simply does not work. This triangle does not exist. Because sine cannot exceed 1, this triangle does not exist, and that side length A is not long enough to reach the base of my triangle. So this problem has no triangle. Once you get there, you will mark that it has no triangle, and then you're done with that example. Okay. Any questions about that one not creating a triangle? So how you're going to know when that happens is because you will get it. Your sine will equal something greater than 1 or less than -1. You are done right there in that problem. Correct.
So what time do we get out of here?
11:10. All right. Any questions right now about this? So we've now seen when there's one triangle, which is when A is greater than B. And then if A is not greater than B, we just have to start and see what happens. This one we started and we found that there was no triangle.
Yeah, that's greatly, significantly not farther than.
Okay, do you have a question?
No, I'm saying like I'm making an observation. The information that's given to us will let us know that B is not.
Yeah.
Facts.
Yeah.
So we wouldn't have to find A to find B. Facts.
Well, we already knew both parts of A, but yes. All right.
So, wait,
So-
we could look at the information that was given already and determine the fact that it was no triangle?
No, because all we knew was that A was not greater than B. And so we knew that we had to start solving to figure out if there was going to be no triangles, or this is a perfect segue, figure out if there's actually going to be 2 triangles. So last example for the day, and I'm going to move to a completely new sheet of paper just because I know I'm not going to have enough space on there. Just because I write huge, you can write at a normal size and be fine. Our last triangle, we know that A is 40 degrees. Big A. Little a is 54. And little b is 62. Okay. I am going to start by drawing the part of the picture that I know, which is this side and the base of my triangle. This is angle A. And then side A is over here. And then this is side B. And that's 40 degrees there. Okay. I know that A over sine of A is going to equal B over sine of B. So I'm going to solve that first. So I'm going to do 54 over sine of A. Sorry, sine of 40 degrees equals 62 over sine of B. So I've started with my known ratio, which is always going to be a over sine of a, or you can do sine of a over a. It doesn't matter which. So this is a over sine of a, b over sine of b. All right, cross multiplying that. I'm going to get 54 sine of b equals 62 sine of 40. After, you have a question? Oh, okay, I thought you were raising your hand. After I cross multiply, I want to get sine of b by itself, so I'm going to divide both sides by 54. These guys will cancel out. So now I know that sine of b equals this whole thing. I'm going to go find what that whole thing equals. I'm going to round it to like 4 decimal places. So it's going to be 62 sine of 40, close those parentheses there, divided by 54. And I get that sine of b equals 0.7381. Or sorry, 0.7380. Okay, right now is where I'm able to determine. So this is the point that I'm able to determine whether it's going to be no triangles or 2 triangles. So if A is greater than B, it's automatically 1 triangle. Can you guys stop talking, please? If A is greater than B, it's automatically 1 triangle. If A is not greater than B, you have to get to this point here, and this is the point at which you determine whether it's going to be 1 or no triangles or 2 triangles. So on the last one, at this point, this was equal to something greater than 1, and sine cannot be equal to greater than 1. So at that point, we knew that it was 1 triangle, or no triangle, sorry. At this point, this is where we now know we're going to have 2 triangles. So from here on out, we're going to split up, and we're going to have 2 possible angle values for B. Here are those 2 possible angle values. We're going to label them B1 and B2. So big B1, big B2. That just says the first one, the second one. So big B1 is going to be second sine inverse of this value here. I'm just going to plug it in. That's going to be 48 degrees because we're going to round it to the closest degree. Okay, then the other time that sine is equal to this between 0 and 180 degrees on our unit circle, 48 degrees would be right here. It would be wherever this is. So it would be 48 degrees from your positive or your negative x-axis. Because this sine value here and this sine value here, because sine is my y value, this sine and this sine are the same. So I'm just going to do 180 minus 48, and my other possible angle is going to be 132 degrees. So I just do 180 minus 48 to get that my other angle is 132 degrees. So if A is not greater than B, and we are able to find an angle, then we are also going to have the same angle in quadrant 2, essentially. From here, we now solve both of these triangles. So I'm going to go ahead and draw what both of these triangles would look like. Our first triangle, just call this number 1 and number 2. So we're going to draw and solve both of these.
Oh, so it's not 2 connected into 1 triangle.
It's 2 separate, it's 2 different possibilities. Yeah. So
it makes 2 new triangles.
Right, it makes 2 completely separate. There's a chance that it would be equal to 2 completely separate triangles. So triangle number 1 is going to look like this. This is going to be a 4. Okay, so this is, sorry, A, B, C, A, B, C. This would be a 40-degree angle down here. Sorry, yeah, 40-degree angle down here. and B1 is a 48-degree angle. And then I know that my side length A is 54. And I know my side length B is 62. And I need to solve the rest of that triangle.
We gotta find side length C and C.
Mm-hmm. Okay. Here is my other option. No. This is the shortcut. Here is my other option. This angle right here is still 40 degrees. I need to draw that even shorter. This triangle would be shaped like this. Let me draw this more to scale. It's not to scale, but let me draw it more to scale because I think you guys need to picture it. So I'm drawing this exact same angle there. I just didn't draw it far enough. There we go. So my triangle would be shaped like this. So this would still be 40 degrees. That's my A. Across from A now, little a, big B, little b, big C, little c. Okay, so across from angle A, my side length A is still 54, but it's 54 going in the opposite direction. Instead of 54 going out, it's 54 coming back in. And then this is still 62. And I now know that B1, or B2, sorry, this is my second option for B, this would be 132 degrees right here. Okay, so I think we're all in one spot now. I think we've got everything labeled that we know. So I want to pause there.
So
What?
8 degrees.
Oh, see? Yeah. Okay, what questions do we have right now? It is a ton of work, I agree. Okay, so this would be equivalent to this triangle can equal this, or it can equal this, essentially. That would be the same length, the same 54. All right, so we need to solve both these triangles out. We can just do our last ratio. So we can use, or we need to solve for angle C on each of these. So Jordan just told us this angle C is 8 degrees because he did 180 minus 40 minus 132. And then this angle C, we would do 180 minus 40 minus 48, 92 degrees. So we just did A plus B plus C equals 180 for those ones. And then we can solve these triangles. We just need to solve for a side C. So I'm gonna use my A's. So I'm gonna do 54 over sine of 40 equals C over sine of C, which is 92 degrees, sine of 92, sorry. For this triangle, actually, I should solve things one at a time. That would be a good idea on my part. So for this one, instead of cross multiplying, I'm just going to multiply both sides by sine of 92, since it's in the denominator. Because then those will cancel. So I'll have C equals 54 sine of 92 degrees over sine of 40 degrees. And that is 54 sine of 92 divided by sine of 40. 84. Okay, so C equals 84 in this one. So it makes sense that that is a long length there, that C equals 84. Any questions about that triangle? Okay, the other triangle would be 54 over sine of 40 again, the same A over sine of A. And that is going to be equal to C over sine of 8. And we're going to go ahead and multiply both sides by sine of 8. we will get C equals 54 sine of 8 degrees all over sine of 40 degrees. And throwing that in a calculator, we will get 11.7, which makes sense. We'll round it to the nearest whole, so we'll round it to 12. So C equals 12. It makes sense that that one should be super short because it's part of this little tiny short side of this obtuse triangle here. All right, so yes, is this a lot? Yes. Is this possible? Yes. There are 3 possible things that can happen. What you're going to do to start every problem, determine if A is greater than B. If A is greater than B, you have one triangle. Actually, I'm going to make a flow chart on the bottom of this page here. So here's your flow chart, and I'll leave this up. So when you have a side-side angle triangle, if A is greater than B, then you have one triangle. Solve it. If A is less than B, then you find sine of B. If sine of B is greater than 1, you have no triangles. If sine of B is less than 1, you have 2 triangles. So those are all the possible things that can happen. Let me know if you have any questions. Okay, I'm going to leave this up here. Freeze. All right, you guys have 35 minutes left to work on today's or Friday's assignment. I should go ahead and pause this video because it's like crazy long.